In this video, we're gonna cover 3 common ways to take arguments from the command line in Bash, and give some real-world examples that most new Bash programmers are searching for. This will help you write multi-function scripts without maintaining multiple similar versions. Hey, it's Newlin here from Stacks Add Up, where I help you learn the technology stacks more efficiently with online video. If you're new here, make sure you click that subscribe button, and if you're seeing value in this video, give me a thumbs up as well. It really makes a huge difference. You can find all the links to everything I mentioned in this video in the description box below. Let's jump into it. I will break the content into 3 parts. The first is to know when and why we need to use the command line arguments. Next comes the syntax, introducing the common types you can take. And then it's examples. We'll be taking the arguments in different ways to know when to use which type. We first have get to know when we will need command line arguments. Take ls as an example. Its default behavior is to list the files in the current directory. But if you call it with an option like -l, it'll show more details about them. So, our programs might act the same most of the time. Moreover, they can also flexibly by taking command line arguments. Let me show you an example of what this looks like to get a sense of it. Let's say we usually connect to a specific server to run operations, but sometimes we may connect to another backup server for some reason. How can we do this without writing 2 versions of codes? It's easy. We can have one for the server IP by checking out the position argument. Generally, we will connect to the IP 192.168.0.1. But if we see the users giving an extra argument when calling our script, that's what lines 4 to 6 are doing. We'll change our target according to what they provide. Now, we're going to see the actual syntax for taking them. There are 3 types altogether. The first one is taking them by their positions. The second is by expanding them all out. And the third is by argument size. The first type is by position. Let's say we're writing a script with 4 often changing variables: ID, name, IP, and port. So we decided to make them as input arguments. When we take some of these arguments, the syntax we'll use will be a $sign plus a number, which is their position number, such as $1, $2, etc. And the users just need to give them in order. The next step is using expansion. The bash can expand some particular parameters into all the arguments passed to the current script. So when you have the need to access all the arguments the user provides, this type can act like syntactic sugar. The last type is by size. Sometimes our script may need to know the number of the arguments user gave. This type is just for that purpose. These 3 types of syntax are pretty straightforward, right? So let's take a look at some real-world examples to see the situations they can apply. We're gonna go through some examples in the 3 types we've just seen. They're by position, by expansion, and by size. All the example files shown here can be found on my GitHub repository. You can find the link in the description box below. Now let's have a look at the first one. Assume we're writing a script to post the testing results onto a data server via HTTP API, and we want this script to post one single entry at a time. Each entry has these values: category name, average response time, bill number, and the data server IP. So how do we catch this value in the script? Let's first write the variable name category and assign the $1 argument to it. Then $2 for the average, $3 for the bill number, and then $4 for the server IP. And below are the pseudocodes to make up the URL and HTTP body for posting. Let's run our script with these values. And we can see it can read our inputs correctly. Great. And if we want to post another entry, we could just rerun the script with different values of that entry. The space character is one of the default delimiters in Bash. But what if there's a case when you just have an argument with a space? Let's try it by giving profile creation as the first argument. But unfortunately, the bash traces us 2 separate arguments. So we have 5 altogether, and there might be a mode function in our script because it only accepts 4. Well, using either single or double quotes can solve the problem. See, now your script can work well as usual. In the previous 2 runs, you may find that the data server IP is always the same, 10.0.0.1. Is it possible to leave the IP out but still keep the flexibility when posting to other servers? The answer is yes, though we have to put those default arguments at the end of the list and enhance our codes. First, we set the IP with the default value. Then we move the original IP assignment code into an if block with the condition that the number of arguments is greater or equal to 4, which means the user gives the 4th argument. And now we're gonna test our codes to see whether it works. When we only give 3 arguments, it uses the default value. And we pass an extra argument, it should take that one. Nice. The next step is using expansion. Say we want to have a script to do backup job. But the problem is that the number of backup targets is not the same every time. So how do we know how many of them we're going to process? This is where expansions come into play. So in our script, the first thing we'll do is print out the total number of directories by using $ and £. Yeah, it's actually one of the expansions too. We can get a number. Let's see whether it works. We have 5 directories here, and we only give it 3 of them. Yes, it printed 3, and we give 5. Correct. So now we can proceed to the next step. Here we're going to use a for loop to process one directory at a time. And this time, we're using $si to expand to all the directories user provides. In a for loop's body, we print each directory's name. Let's run our script and give all of them: src, static, templates, tests, and utils. And yes, it prints out all the directory names. And if we add the actual code to call the tar program to compress them, in the end, the current directory will have tar files for the directories we selected. Here we are at the 3rd example. Now I want to show you this one on a bigger scale. I will make a tiny but handy script that involves many skills you might find helpful. This script will accept the file as input, randomly pick one entry from it, and print it out. This feature is useful when you want to build up lots of profiles or database records, something like that, for testing. Additionally, we provide an option to specify how many times the picking will repeat. As we go through the script, I'm going to show it step by step so that you can have a sense of how a script is developing. Let's go. First, we take a look at the input file. It has 10 first names, very suitable as a sample file. Then, we use a text processing tool called set to get a specific line from that file. When we give the command 1p with the -n option, it will only print the first line of that file. And when we get 2p, it will print out the second line and so on. Let's try 6p this time. And yes, it shows JSON. It sure is the 6th name. So now we know how to get a line from a file. The next step is to do it randomly. Bash has a predefined environment variable named random, which will produce a random integer between 0 and 32,767 every time you reference it. So we can use it to make an arbitrary line number. And since our sample file has only 10 lines, we need to make sure the random numbers are between 1 to 10. Here we use a bash feature called arithmetic expansion to calculate. We first write the random variable name, then mod it by 10. Adding 1 to it is required because the remainder could be 0. And we quickly test this code snippet. And yes, all the generated numbers fall within 1 to 10. Now we can have a random number for the set command. So randomly picking a name is no longer a problem. I want to show you the next step is the sec program. It can help us generate a sequence of numbers which we'll need in a for loop later. If we invoke it with argument 3, it will produce 1, 2, 3. And if we do it again with 10, it will produce 1 to 10. Then we can define a variable repeat to hold the number of picking times and pass it to the sec. Let's wrap the current steps we've made so far in a for loop. First, we have a variable repeat to hold the picking times. And then a for loop where we use sec to make a list of words to loop with. We just print the debug message first to check everything's okay in the body part. And run the script. And yes, it printed 4 lines of messages. Now we can put a random picking snippet into it. We can see our script pull 4 names randomly from the file this time. Then comes the meat of this example, the arguments. Here we're going to take one from the command line as the source of names by simply assigning the file variable with the value of the first positional argument. We can now pick names from a different file. But wait, what will happen if users forget to give that argument? Let's try it. Lots of errors say there's no such a file. So here we add an if block to check whether the number of arguments is correct. If not, we'll warn users and exit our script immediately. Let's see if it works. Yeah, it prints an error message about that. Good. Now we're going to process the options part. In this case, we just have one, repeat. Let's jump to the line where we assign the repeat value. Previously, we set it with a fixed value. Now we set it to 1 as the default. So if we run our script without any options, our script will only pick a name. Next, we'll use a while loop to process the rest of the arguments. Here we set the looping condition as $, greater than 0. It means this loop will continue when we still have arguments. Each time in the while loop, we check the first argument to see if it matches the following patterns. The first pattern is our target option name, repeat. So if the first argument matches this pattern, we then use the command shift to pop it out of the argument list. The following argument should be the repeat number. But remember, always consider exception handling in your script. So we test the following argument first to see if it has a value. If not, again, tell users about this and exit immediately. If yes, we then take that argument as the number of repetitions. And use shift again to pop the number out. The second pattern is for other options we don't recognize. For this case, we simply warn users and exit the script. The third pattern is for dumping the positional arguments out, like our file argument, because we've already got this value in the previous section. Now, let's test this chunk of code. First, when we call the script only with a file argument, it will only pick one name from that file. Then when an extra repeat option but misses its value, the script would warn us about that. And when we give the correct format of arguments, it will pick the right number of names for us. Before wrapping up, we should do one more thing in our script, usage message. Users can remember all the positional and optional arguments, and often the users are the future of us. So, leave a message to remind us how this script works is a good idea. Let's do it. First, I decided to make it a function since we will need it a few times in our script. Next comes the body part. We use a bash feature called here documents to make a file-like argument on the fly for the cat program. It begins with two left angle brackets, followed by a delimiter string, then the file content, and a delimiter again. Please note that the delimiters must be the same, or Bash will not know where to stop. And make sure you pick the delimiter string carefully. If your content happens to have that delimiter, the document will end up early. Finally, after we have a very descriptive usage message, we can replace those error messages with this one. So now you can test the script with each exception we've shown you before. Okay, let's review what we have learned today. We now have a powerful tool to add flexibility to our script for changing its logic on demand. Like the ls command, we could list file names and ask it to show more details when we want to. And there are three types to taking them in our scripts. The first one is taking them by their positions. The second is by expanding them all out. And the third is by argument size. I also introduce you to some real and useful examples in those three types to enforce the knowledge we've just learned. Hope these materials can help you equip your script with more powers. Do you feel that you got a lot of value out of this video? If so, what did you get out of it? Please leave a comment below and let me know what you think. Now, if you're interested in checking out more tips as well, then I put together a PDF guide that is linked in the description box below. This runs through the most common questions that can help you save time on debugging and spend more time creating values. Make sure you're grabbing your free copy of my guide, and I'll see you in the next video. Happy stacking!